Back, guys, to learning Solidity chapter 3. In our first tutorial, we covered and actually constructed our very first smart contract. We went through the anatomy of the smart contract, how it works, went through all the lines of codes, the setters, getters, and receivers. We constructed our first contract and deployed that in the blockchain, which was super cool. So all of you guys who got to do that, congratulations, you did that. Our second chapter, we implemented inheritance and other sorts of complex features into our smart contract, therefore transforming it into our kind of own personal bank. We can do our setters, getters, and senders, kind of receive money, send money, and also we added a little bit of a loan function in there as well. So we kind of were the admin of our own bank, which is pretty cool. And now in our chapter 3, guys, we're going to be covering our modifiers and error handling. They do kind of go hand in hand, and we're kind of be going over the baselines as to what are some basic errors that we make when coding, and other sorts of especially with our modifiers, actually adding even more complex functions and commands to our smart contract to really give it that smart value. And actually, before we really do get started, I actually do need to cover an error that I was. As you can see here, I did have my return value, the amount. This should be check value. I actually did kind of catch this at the end when I was done editing and when I was going back and reviewing my code. I actually got an email on it too. So I will get this updated in the GitHub. This should be updated by now. By the time this video comes out, this should be check value for all those. For all you guys who are having issues for your compilers and weren't being able to get to the next step. So hopefully that wasn't too much of a handle for you, and if so, you maybe figured out before this video even came out. But awesome, guys, I will see you guys over in the next chapter where we get started. The meat of our contract here, you can notice that we have a couple different things going on and some things that we will be implementing. So we will be implementing a modifier into this contract, and we're also going to be implementing a couple new functions and setters going under the terms of send, receive, address, and admin. So one of the very important things to definitely notice first off in our contract is that it is not secure by anyone. So we have no admin functionality, or the contract does not know that we are the sole creator, therefore giving edits to basically anybody who has a source code. And if you are handling smart contracts in terms of the bank, like we are, or in terms of funds or financial services for flash loans or any sort of auditory process, it's important to let the smart contract know that you are the only one who has the power to construct and edit this smart contract. And once it is deployed, it is uneditable. But as we are continually constructing it, it will therefore let us continue the functions of the admin. So what we will do now is we are going to add our address, and it's going to go address. Then we're also going to go over to private, and then we're also going to go to owner, and then don't forget to close those with parentheses. So we all do make errors actually here and there. You can pause the video here if you'd like to. Definitely forgot to implement our function into our constructor bank contract, which is starting from line 8. Of course, it is a different setup, depending how you have your UI laid out, but you can pause the video and implement this function bank value and owner into your contract underneath the contract bank as regulator. And let's also cover the address private owner. I did actually also forget to cover this. So for those who do not know address is just stating, and also the private, that we are the sole admin owner of this contract. So the address should be following back to us as the owner, and the private implemented here is so for their giving us the security in terms of this is not publicly accessible to everyone else on the blockchain. This is specifically just to us right now until deployment. And sounds good. Now that we have those out of the way, let's actually continue into our next. So what we can do now is that we can kind of get down to line 12, and let's actually imply our modifier, and we're going to explain this a bit further as we keep going. Modifier, and then we're also going to be going over to owner, and then let's do, I think that's a couple of func, and then close parentheses, drop that down, and then require, and then do owner as well. Awesome. And then do our little equal signs, message, dot that to sender, and then close that with our wink. Awesome. Underscore, and then we are good to go. So let's actually break this down here quickly, and let's actually kind of break down what we just wrote here. So the reason we amplify this modifier with the owner func requirement, and also going down to the message sender, and why we need the semicolon at the end with also the underscore is also to extend those functionalities that we just implied in our modifier. So that's letting our contract know that we need to execute in XYZ steps. So if you guys remember in chapter 1 how we talked about you can't have step 2 without step 4. So that's exactly what we're telling our contract now, to execute all following functions beforehand in terms of before we get to the owner func, and also going over the modifier of the owner func up here for line 12. This is also implementing and telling the smart contract that this is an only admin functionality that only can be used by the contract owner in terms of modifying and continuing to develop this contract. So that's all you need to really remember with the owner func. And there are a couple different test throw methods that we can do, and we will continue showing those as we continue to progress through the tutorial. Okay guys, we can continue to move. This tutorial was a bit different. It's about attacking 2 sectors in one video. So we are doing modifier handling and error handling as well. So one of the cool things to remember also is when you're constructing your modifier and also remembering the require function. I did a test down here for function test throw, and there are function test throw or test throw, revert, and require. So some of these, so there are some of instead of using require, that's one of the reasons I use require in the modifier, but you can use multiple different test functions within your function to combat certain materialized actions within your contract. So for example, we can even do like function here, we can go function and then revert, or like we can do test revert, and then if we did like cover that as well, and then we could also do like function revert. All of these are, don't forget your curly braces at the end, your closed signals there, but these can be used in terms of anything in replacement or require. It really is all preference, but also do remember in test throw, in some of these functions, especially as we continue to develop in Solidity, some of these may become obsolete and not available. So I do not recommend using test throw, as that may be outdated and no longer supported. But test revert and also revert also, I believe, are still welcome and good to go. So that's always one thing to remember. Solidity is always an evolving language, and it's got a lot of changes going on consistently. So that's just a good thing to remember, guys, in terms of when remember handling errors. And usually the most common errors are very small in terms of switching your syntaxes and underscores, for the correct compiler to give you the thumbs up. To the modifier section, what you can also notice is that we've added our owner function or owner func to the end of our function withdraw and our function deposit functions. So what this does and how this can kind of really start, you can really start cutting off access and really start modifying the smart contract even further, and you can start limiting in terms of kind of admin power and how the smart contract can navigate. So what these two did here, and we will compile at the end of our tutorial and really go down in depth as to see how these functions and these modifiers are playing together. And you can see that our owner func here has now been applied to our deposit and withdraw. So when we do get to our compiler at the end, when we do try to give actions outside our admin our admin adjustments, it should be giving us false errors in terms of letting us know either not an admin control or you do not have access to this requirement, etc. So this is the example of how modifiers can be added to functions for a more in-depth control in terms of when you're modifying your smart contract, whether that be for finance deployment or anything that requires capital. It's important to remember to add that extra layer. Now let's test this actually in action. So let's test our required function and see how it works. So for those who may not have everything compiled, go up here into our deploy and run transactions. I have 10 in our deposit, so this is kind of what our interface looks like for those who have been following along. So when we click deposit for 10 or whatever number you would like to choose, we should be getting an error back. And also remember to important, switch the Ethereum addresses. So these are all fake Ethereum addresses with fake money. The remix, of course, you guys know, is just used for testing. It's a great IDE that we use before we really get on the network. So just choose anyone random. I'll just choose another random one just to make it easier since we have 100 Ether. So it should be giving us a X in terms of we should not be able to do this. Awesome. So that's exactly what we wanted. So it actually gave us an error saying we cannot deposit those funds into our bank account. And why is that reason? Exactly this reason up here for our modifier under our contract. If you guys do remember, we did implement this require function and also put in our owner functions and put in our owner functions inside our original functions to therefore make this a bit of a closed off contract. So in terms of right now, we technically are not under our admin address. We are under a completely different address, the basic user. And now the contract has alerted us that and said, hey, you are not the original user. You cannot do this. So this was kind of a live example, kind of how you can implement these security checks in your smart contracts and kind of give off some cut and entrance functionality and better ways of navigating your smart contract, and definitely making things more compatible for yourself and others, and kind of just really showing the control that you can have when constructing these contracts. And also to branch us off into our second tab here, and we wanted to also, or at least for me, I thought it was super important that we also did cover assert, require, revert, and throw, also in kind of in a more in-depth manner. So I wanted to pull up kind of some definitions, as I didn't want to steer you guys wrong and kind of give you guys the wrong interpretation, because we do mess up too. I'm by far no any means perfect, but definitely sometimes the terminology can get kind of skewed sometimes, especially with the ever-changing compilers and of course Solidity versions. So the Solidity, assert, and require are converse functions that check for conditionals in case when conditions are not met. They are throw exceptions if code is well written and is result in a failing assert statement, such as issues, signal bugs, and contracts. You can find tools helping you test contracts and find potential problems. There are also cases when Solidity creates asserts types of inspections. We actually have not covered assert types just yet, but definitely want to get those definitions on the board for you guys, just to kind of give you the clear-cut definition, just so it doesn't confuse you guys, or if I said something wrong earlier in the tutorial, you guys aren't too confused by it. And I'm also going over to our revert protocol and to how that allows us to continue our value, and what really that does when we state revert is that it can allow us to return the value. So like, for example, here, this was a good reminder for myself as well, that it will look at something like this. So revert something bad that happens, or require conditions something bad happened. That doesn't always mean that something bad happened, but it's very common in terms of gas prices, when the gas requirement is not met, that the revert function is used to return the gas fee to the sender. That does not always happen correctly, and it's not always promised. But as we continue to move forward with the Solidity compiler versions and overall Solidity upgrade and scalability, I believe that will be something that is more common. And I believe we did cover everything along the basis, guys, in terms of what I wanted to cover today. Actually, there is one more thing I would definitely like to implement in here, and that is the access modifier for the internal and external compatibility. So for example, that would be, and I have carried over the contract bank regulator into our our other test tab over here. And what I totally forgot to mention is that something you can do as well is we already had our owner functionality, so that of course interpreted that it is the admin and only the admin that can execute these functions and these commands. But what we can actually do, which is actually super duper cool, is that we can have the public here, right? But easily, for example, you're an admin, and let's just make up a hypothetical example. You're working in a bank, you were the admin of your bank team A, and let's say bank team 2, your secondary in command, needs access to the contract as well in terms of understanding the funds and placement. So what we can easily do is that we can take out the public here for the access modifier, and we can do private, so that can implement the function withdrawal for the private section. And one thing we could also do is we can add, if we were to take this away, we can do address, and then of course it can be whatever that may be. So if we wanted to do like a 0x1a, let's say, for example, just for hypothetical examples, this would be our guy, and then we can implement his address here, and I could just type a bunch of random letters because it's really all it is anyway. So, and then address so and so, and that would be able to basically be able to extend that functionality to him as well. So he would be able to withdraw from the designated account with the admin function of thumbs up, that would be us, and be able to proceed with his duties. So thank you guys so much for tuning in to Learning Solidity Chapter 3. Chapter 4, we will be covering, I believe, let's take a look at our schedule, what we'll be covering next. We will be covering imports and libraries, so that will be a really good section as well. The source code will be down in the description, along with the GitHub for anyone who had trouble with their compilers, or maybe got lost and didn't understand exactly where we were. No worries at all, guys. Just stick with it and continue to to learn and do what you do what you guys do best, which is coming here and taking the content and making the most of it. So thank you guys so much. I will see you guys in the next video. Bye bye.